In this video, I want to show you how to model stairs. Um, and I don't know that we'll be able to do any more than just modeling a single flight of stairs as people move from one floor to the bottom of the flight. Uh, the fortunate thing is, of course, all we have to really do is model if we want to. I don't know that we even need to. Is to model just a few flights of stairs just to get a sense of how flow works in those spaces. Anyway, setting up stairs is pretty straightforward. It begins with selecting the stair button, clicking on a rectangle. One of the things that I do know is that the standard stairway is 4 feet in width. I think that's what code is. It may or may not be, implemented that way everywhere. And of course, our mileage will vary depending on the way that buildings were designed. And then the other thing is that the width of the stair, the depth of the stair, the tread of the stairs, it is roughly 11 inches. I think is the norm for code. So let me show you how this works then. So if I want to create a flight of stairs that is roughly 10 feet, again, assuming my grid is 1 foot per grid, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 stairs. And actually, let me extend this out. Well, actually, let me just I'll make it 11 feet, and there's a reason for that. Okay, so, and let me move this down to the bottom of the stairwell here so that it's right next to the wall. And I'm going to actually extend this all the way down to the bottom just so that I don't have simulants trying to run through that empty space that's there. All right. So, so for 10 feet, that's, if I might need a calculator here. Maybe I should have made that 11 feet. Actually, let me make it 11 feet. But let me show you in a calculator first. All right, so if I have a stair that is 11 inches, and then I want to extend that for how many, essentially 10 feet, or I want 10 of those, I'm going to need 110 inches total for my stairwell. And so that is essentially a little more than 9 feet. And so I can set it up that way, or I can just say, you know what, roughly 10 feet for 10 or for 10 steps. And so this is where the tread count can come in. I can extend my stairs for 11 feet. I'm going to say I'm going to have 10 treads for that. And so it's going to essentially then create 10 different steps here on my landing. Fortunately for us, we can just we can approximate how many steps that we're going to need for various stairwells that we have. If we really wanted to get down to it, I suppose I would go and try. I wouldn't want to actually go and count. I think it's not actually that important. All we really need to be able to do is model having people come up the stairs or go down the stairs, basically using the same approaches that we've used before. In this case, I'm just going to set a target point. Actually, let me move the target point up the side here. I'm going to create another target point up here for people coming up the stairs. What did I just do? Try that again. Oh, I did it again. Sorry. I have to actually select rectangle. There we go. Okay, so there's my target point. And make sure I set the IDs for this. So this is going to be ID 3. I'll make this one ID 2. I'm going to have the spawn point go to 2. Is that right? Did I? Yeah. And then I'm going to have another spawn point down here. People coming up the stairs, and they're going to go to 3. And how many people? I'm going to have 5 people coming up the stair. Yeah, whoops. And I'm going to have 5 people going down the stair. Oh, by the way, there's another thing that we have to be able to set here. That's the upward direction. So upward direction in here basically is saying that it's going in the X direction, up in that direction. Again, I don't know that it actually matters for us, but if I wanted to set the other direction, oops, that's not what I wanted either. Right. Maybe it's negative. It might be that it has to be negative to go negative X direction in that way. So, all right. Either way, it doesn't matter because we're not going to do multiple flights. All we know is that these are going to be at different levels, and then we just go ahead and run the simulation. Make sure I've selected a model. Yes, I have. And I'm going to run this. Okay. So one of the things to notice here, actually, let me go back and let's go back and look at what happened there, because I think that there's some other configuration that we need. You'll notice that when these simulants come down the steps, they're going like shortest path. So, you know, the shortest path between 2 points, right? Straight line. So that's what they did. I don't blame them that they don't have the social norms built into them. So if we're modeling steps and we want to stick to a social norm of, let's say people go, stay on the right-hand side, then I'm going to have to set a target point over here on the right-hand side, right? And same thing with this target point. I'm going to have to set that on the right-hand side. Otherwise, these guys are going to violate, you know, the norms. So now, now when I have them do this, go ahead and run it, you know, they stick to their side, stay in their lane basically. And, you know, perhaps that's one of those things that we want to be able to mention to people as they're having to traverse, you know, steps and whatever else. And that, actually this becomes a problem when, and we'll have to find some other ways to model this, because we want to be able to force people to come down a certain side, but then if they're crossing over to go to some other location that's, you know, maybe a hallway at the bottom of the steps, then they're going to have to follow some type of social norm to do that. So the way that we model that, I guess, is still up for discussion on how we want to do that. But anyway, I think with what I've shown you here, I think we can reasonably model the way that steps will work, and then also to be able to stick to a certain type of norm, you know, in terms of how do people come up and down steps. And again, in this case, because I've changed it so that we have these target points on basically right side of the steps, we can see that we can keep the trails in a certain way. But if we go to another norm, which let me show this one, if we don't model it properly, then we're going to get behavior that, you know, basically isn't quite what we expect, especially with the people coming down the steps. You know, if they're going down shortest path and staying down the left-hand side, obviously that's going to cause issues. So, all right. Anyway, so that concludes the video on modeling stairs.